All right, so we're finishing up the lesson we were talking about yesterday, which was lesson 312, where we were discussing how to find solutions graphically and algebraically. So she can't figure out how to solve this algebraically because it's kind of beyond our skills right now. And so this is where we have what we've got. And so she graphs these equations and she gets this graph. And so she thinks there's no solutions because there aren't any in this picture. What do you think? And so as I look at this graph, I see that, yeah, there's no solutions. They do not meet on the picture. But they look like they're headed towards each other as we move over here. Like they look like they're going to get each other there. They look like they're going to get each other there. So what we call this is a problem of the viewing window. And so that means that there probably are solutions. They're just not in my picture. And so to find them, I need to change my picture. So I think, yes, there are solutions. And to find them, I'm going to go ahead and head over to decimals. So in decimals, I type the two equations, 20x plus 1 and 3 raised to the x. 20x plus 1 looks like this. Notice that my window goes from 0 to 5. And then it goes from 0 to 100 that direction. So it's just a little bit. I've kind of got it centered up funky off that. So, but that's what it is. It's counting by tens this way, counting by actually fifths this way. But if we just pay attention to the dark lines, 5. And so when I click this, oh, look, they seem to meet twice. So I'm going to click right here on this one. And one of the answers is 0, 1. And the other answer is 481. So let's go ahead and write both of those down as our answers. So it was 0, 1 and 4, 81. So there definitely are solutions. And what would it look like now? So should it be these ordered pairs that I found from my picture? Will it be a single number or coordinates? Now, looking at this, is there a y in this equation? And there's not a y, so it doesn't make any sense for it to have coordinates for answers. So we just need our two x values. So they're going to be a single number because there's no y. So we just need our x values that we found from the graph, and that would be x equals 0 and 4. So those are our two answers. And it looks like there should be an algebraic way to solve this problem because we got really clean answers. So we'll have to figure that out later. But Yahara's teammate, Emma, started by subtracting 1 from both sides of the equation. When she graphs her system later, she uses these two equations. Will she get the same solutions? What do you think? Should it matter that she subtracted 1? I think so, but let's decide. Write your conclusion down, and then we'll go back to decimals. Test our set using decimals. So what we're going to do here is we're going to take this one off and move it over to that one. And so picture looks similar. Yep, 0, 0 instead of 1, 0, 1. And 480 instead of 481. Notice that the y values have both decreased by 1. And so, but did she get the same answers? So yes, sort of, because her x values are the same. She got 0 and 4. But she did get 0, 0 and 0, 80 because the y's shifted 1. And so, but we don't need the y's. So the y's have changed -1, but the x's are the same. And so while the ordered pair intersection is different, the x values are the same. So it's still the same solutions. Why can't we solve this algebraically? What is the problem? And the problem is we don't know how to undo anything in the exponent there right now. I can undo it. You're going to learn how eventually, but we don't really know how to undo it right now. And so since we don't know how to undo it right now, we're kind of stuck with just these graphical approaches. So discuss this again with some people in the room. Decide what you think, and this is what I'm saying, and it's good, but decide what you think and write something down about that. So Jack is trying to solve this equation. He graphed these functions at the right, and he's got this. Use points A and B to solve the equation that we wrote in the picture. So what equation is he solving? He's solving this equation, 12x equals negative x minus 3. And this should be squared based on the picture. So that should be squared plus 4. I'm judging that this is a parabola, not a line, so I'm going to make it squared. And use points A and B to solve the equation we wrote. So we know that A is 3, 4, and B is 4, 3. And will there be more answers? And I think so. I think eventually these two are going to intersect each other eventually. This is going to keep going this direction, and that's going to keep going this way until it hits the asymptote. There's an asymptote. But I do think they'll meet, even with the asymptote there. And so let's figure out what's going on. It says to use the points to help us solve the equation. And so I'm not sure how that will help us, but I'm going to go ahead and get rid of x from the denominator here. So we get 12 equals negative x, parentheses x minus 3 squared plus 4x. And so what I've done is just times everything by x. This whole thing got times by x once, and the 4 got times by x. Write that in blue. It led to that. And so this is what I'm trying to do. We know the answers. And what I noticed right here is this is x cubed because there's 2 x's here and then 1 there. So getting 3 answers is actually very reasonable. 12 equals negative x, parentheses x squared minus 6x plus 9 plus 4x. And again, that's that tricky distributing thing. Negative x cubed, positive 6x squared, negative 9x plus 4x. Minus 12, I'm going to move that over 0. And so negative x cubed plus 6x squared minus 5x minus 12. I feel like I'm running around in a little circle here. This is not going to be the most helpful thing in the world. My x values are 3 and 4 though. So I know, what do you guys know? Let me pause and think about this for just a minute, what I can tell you. I think I've taken you on a kind of an algebra roller coaster. We don't really know how to solve this yet. I do. You don't. And I'm not sure if this is the place where I'm supposed to show you how to solve this, which is basically factoring. And I don't think you've factored x cubed yet. But I'm going to go ahead and pull out negative 1. 0 equals x cubed minus 6x squared plus 5x plus 12. We'll have the same set of answers. And as we discovered yesterday, you can graph this and look at the roots to decide what the answers are. And so one of my roots is 3 and one root is 4, and then it'll help me find the third root, which my guess is probably 1, negative 1, because of 3 and 4 and the relationship they have with 12. And so 3 times 4 is 12, so the only last number left is the 1. But I'm not sure. Let's go ahead and go to Desmos and graph that. So get rid of both of these. Go to regular window. X cubed. Let's actually do the negative x cubed. Plus 6x squared. Looking back at the equation again. Plus 5x minus 5x minus 12. Yep. So 3, 4, and negative 1. And so, and I can explain to you when I'm present how I figured out that it was going to be negative 1. But there's my graphical answer along with the simplification of the equation first. And if I zoomed out on the picture, I could see it graphically as well, which is probably what they intended. They probably didn't intend you to go down the rabbit hole of doing all of that algebra. They probably expected you to put them on a graph and see what happened. So I apologize for the algebra hole. But sometimes we that's where my brain goes first, and we're not really ready for that. So the answer is -1, and I don't know what would be when I plug it in. Actually, I do. It's going to be -12, because when I plug it in that's what I'm going to get there. -1, so -4 squared, which is +16, and so -16 plus 4 is -12. So that's the ordered pair for our third one, which is where those two are going to intersect. And so we can show by plugging -1 in, I get the same answer. By plugging 3 in, I get the same answer. By plugging 4 in, I get the same answer. And so that's the idea. I'm going to come back and finish the lesson in another video.